Okay then, we've been through the theory of RAGAS, so let's look at some actual example of how we can use this system. Now we've got some long workflow that we're going to be dealing with. We got quite a lot of calls to make in order to get everything in the shape that we need it in for RAGAS to do whatever RAGAS does and get us the metrics that we need to evaluate these systems. So I'm going to be breezing through this notebook. You can get this notebook and have a look at things in slow time, but essentially what we're going to be doing is creating this data set, which means we're going to start, if I zoom in here, we're going to start with the Theft Act, 1968 from the UK, just to give us a bit of a document that's going to have some challenging legal vocabulary. And what we're going to do is we're going to set up one RAG system which is going to use GPT 3.5 and a large embedding model, a powerful embedding model. And we're going to have a system which is going to use the latest and greatest GPT 4.0. However, that system is just going to rely on some sort of small embedding model. And so we're going to be able to run RAGAS, get some evaluation metrics back for both of these systems, and see which one turned out to be better. So I'm going to breeze through this, like I said. We're getting LangChain, we're getting RAGAS, we're getting some PDF document loader. Here I'm pulling in this PDF and we're loading it, and we say we get this initial separation of the data. It's already got some form of chunking, but of course we're not happy with that. Every item of this list is a LangChain document with the page content, with the text and all the metadata associated with that. We want to split this document up slightly differently. It's a legal document, it's got its own format. So here with this character text splitter, I can define some regex, and with this regex we're defining, okay, we've found this pattern, split my document up into another chunk. And here we get a load of warnings because I placed some limit on it, and because of the way that this splitter works, some of the chunks are larger than that size. But at the end of it, and of course this is part of the process that you want to pay excruciating attention to in order to make sure that these documents that you've split your text into are in fact coherent. So this is the legal document. I just printed out some examples on the screen here so you can see that we're basically getting back the paragraphs, and a short sentence without a full paragraph in a legal document is pretty meaningless. They tend to be long, rambling paragraphs, and you need the whole paragraph to have something coherent. So that is it. It's not been perfect splitting up the documents, but we have got something which is approximately correct. So the next step is to bag up those documents. So we're bagging them up, and what I mean by that is we're putting them in a vector store. In order to do that, we need something that's going to create the numerical representations. So we get on the one hand, a BGE M3, a large, powerful embedding model from Hugging Face, and we're going to get a smaller version of this BGE model, which is the one we're going to put with 4.0, and we're going to put the large one with 3.5. We're going to see which system is better. So we've got the embedding model. We're using ChromaDB to save this database locally, specify a location, give it the documents we've created, give it the embedding model that we want it to have. And so essentially we've now got these two different vector stores. We've got the large one with the large embedding model and the small one with the small embedding model, and we can test if they work. Is it okay to take wild animals? And we get the passages of text that we found from our Theft Act 1968. We get a passage which says wild creatures tamed or untamed shall be regarded as property, etc., and so on and so forth. Now, in order to be able to just use these as a retriever. We're just going to give them a query. We turn these vector stores into retrievers. Now we're just going to be able to use the invoke method to get out what we need. Now we need the large language model. We've got 4.0 here, and we're going to be using 4.0 to generate our questions. And you'll see in this next part of the code, and I encourage you to go and play with these methods in slow time. Basically, we want to ensure that what the large language model gives us in terms of its format is what we're expecting. Otherwise, we end up with the whole evaluation falling apart. So we can use this structured output parser. We've suggested a schema for the output, and we can get out of that some formatting instructions which are going to be useful. Now, we've got this prompt which is being created here. It's just a Python string. We've got some variables we can put in there, which are the format instructions, how we want this to come out, and the particular piece of context, and we ask it, generate me a question that can be answered by this context. So that goes into an instance of LangChain chat prompt template, and essentially we get out this, which is going to be passed to the large language model, GPT-4o. It's going to generate us some questions. And I wouldn't worry too much about the format of what I'm doing here in this code. Essentially, we are going to pass to the large language model a human message. That's another type in LangChain, and you can see in there is the totality of the prompt that we're going to pass to the large language model. Essentially, I've just created a chain, and have a look at that notebook in slow time. And with that chain, we can call the invoke method, and we can give it the message that we've created. What's it going to give us out? It's going to give us out the question. Okay. Right here. So we've got this chain set up to be able to generate questions, and essentially then this is the code that we are going to be using to generate the questions, and all we say to it is, yeah, go through our documents. Then we create this this prompt, this messages prompt. We get some format instructions, and we get a response, and that's a generated response, and we're saving that into a dictionary. We're saving that into a dictionary. Into a field called context, we put the text, and here we're just starting to generate these triplets, which is going to be our questions, our context, and our response. So however you do that, however you set this up, that's essentially what you're going to need, and you're going to see that in a little while. After we've set up this question sort of generation pipeline, we're setting up this answer generation pipeline, and so for this we end up with another prompt, which is going to say, okay, answer the question, here's the context. And again, we create a human message, which is going to go to the large language model. In there, you've got some formatting instructions, etc. I'll just check the time. We're at 9 minutes. We're okay. And essentially, all I'm going to do then is I'm going to loop through. I'm going to loop through all these questions and context that we got before, and we're going to go and get this answer generation chain to give us an answer to those questions, and then we're going to save that to the answer. Now, once we've got that, what I'm going to do here is, and if we just uncomment all of this out, is we import data sets. And in this case, I'm just making a pandas data frame because we can convert to a data set from pandas. And the important thing to note is that RAGAS is going to get a data set with the fields that it wants. And the fields that it wants are going to be called question, context, and ground truth over here. So we generate this data set, and there you go. We can access it like any data set that we're familiar with. In this case, like I said to you, it's got those 3 fields. I've just done 12 examples here, just for us to get the idea of this whole process: question, ground truth, context. Now we've got this evaluation data set. We're going to have to start thinking about creating the chains for the systems that we are going to be assessing. So I'll come back in the next video and we shall go through the final part of this notebook.